Associate Director of the Faraday Institute. I'm afraid I won't be here all weekend because I'm flying off to Japan shortly. But I am here today to hear Sir John Houghton, and I'm very glad indeed to introduce him. He's had a very distinguished career, and you can read about it in the handout. I won't even mention all the degrees he's been given, honorary degrees, there's so many. But most pertinent, I think, to today is that he was Director of the Met Office, and he was deeply involved in all the negotiations of the Intergovernmental Panel on Climate Change, which led to the Kyoto Agreement, and produced quite remarkably, I think, a document documenting the reality of climate change, which was approved by over 100 scientists from all the nations in the world, basically. And we're in agreement. I think it's a remarkable example of the sense in which science can bring together so many disparate nations, religions, backgrounds to a common consensus for something which is a global problem. And Sir John played a very large part in that process, which stands really as a monument to him. He's also just this year received the Japan Prize, which is a very prestigious prize, and many other prizes too. The other thing I want to say is that he is a practicing Christian. He is chairman of the John Ray Initiative, which is a Christian group concerned to address the reality of environmental change from a Christian perspective and to speak into society about that. And that also is playing a very significant role behind the scenes. And I think we'll see the fruits of what he's been doing over the years to come. But today he's going to talk about climate change. I think you've just, you better hit this before it dies. It's come back in. He's going to talk about global warming and society's response. So without further ado, I'll hand over to Sir John Houghton. Thank you.
Thank you, Bob. It's a great pleasure to be talking to you here today in Cambridge. I gather you had some presentation from John Gummer last night, which involved global warming and this whole business of climate change. And John is a man of whom I have great respect. When I was in the 1990s, I was chairman for 6 years of the Royal Commission on Environmental Pollution, which is a standing Royal Commission in this country. And John Gummer was Secretary of State for the Environment during a substantial part of those years. And I saw quite a lot of him, and he was a great Secretary of State, and in fact his department, and it is generally recognised, he's one of the very best Secretaries of State for the environment that we've had in this country. Not least because he actually believed in what he was doing. He was passionate about caring for the environment, but he's a very realistic politician, and he tried to do some things, and some things we tried to persuade him to do, he saw as politically impossible or politically not achievable. And some things he wanted to achieve, he achieved, and some other things, particularly concerned with waste, he failed. So it was marvellous to see him in action and to see him in operation in this whole area of trying to care for the environment. And I was trying to stand back so that you can see the screen. I should first try and explain to you a bit about the science, the impacts in summary form of global warming, and then we'll talk a bit about the response and what we can do about it, and the problems of educating people and all these sort of things that David has been putting in front of us also earlier this morning. But before just getting to global warming, let me remind you, although it's said to be the biggest problem we face, and I think that's probably true, as a human race, the biggest environmental problem, and maybe even one of the very biggest problems we face, there are other issues. And I thought I had a different slide of that. My apologies. A list of other sustainable issues. Let me suggest some of them to you. There's population, there's the problem of clean water, there's the problem of sustainable energy for the poor in the world, the 2 billion who haven't got any. There's the problem of the rich-poor divide. There is the problem of fish. There's the problem of forests. There are some very big sustainable issues. There's the problem of resources, which is the developing world is very concerned about the increase in population. The developed world ought to be very concerned about their overuse of resources. I don't know if John Gummer told you last night the thing he says when he goes to America. Did he do that?
No.
when people say, oh, but Mr. Gummer, isn't it the population of the world that's the big problem? You see, population growth and all that sort of thing. No, he says, absolutely not. The problem is not the problem. He says, let me get it right, the population, it's not the population growth in the developing world that's the problem, it's the population growth in the developed world. So they say, but Mr. Gummer, we're hardly growing at all. But he says every American child who is born uses 120 times the resources of every Bangladeshi. So it's in fact the growth of the American population that's the problem, not the growth of the population in Bangladesh. And so we have to put climate change in the context of these other problems. And solutions to climate change also have to have some bearing on these other problems in the world that are so very large. So what is global warming? The basic physics has been known for a long time. Solar radiation comes in and warms the Earth's surface. That energy input is balanced by infrared radiation, thermal radiation, heat radiation leaving the Earth's surface. Some of it gets out to space, but a great deal of it doesn't because it's blocked by greenhouse gases on the way. Greenhouse gases are water vapor, carbon dioxide and methane are the most important. We humans aren't changing in a primary sense the amount of water vapor in the atmosphere. That changes as a response to other factors, but we are changing very substantially the amount of carbon dioxide in the atmosphere, because we're burning fossil fuels, coal, oil and gas. This is another context slide, the last 160,000 years. The last ice age is on that diagram. It finished about 20,000 years ago. The last warm period was about 120,000 years ago. How do we know all this? We know it very largely from boring out cores of ice from Greenland or Antarctica. These cores are kilometres long because the ice is kilometres thick, and as you go down through the ice, you go backwards in time. You can measure the temperature which the ice was laid down by looking at the ratio of the isotopes of oxygen. You can measure the composition of the atmosphere by looking at the bubbles there that are trapped in the ice. So you've got a temperature curve there for this period. You've also got a carbon dioxide curve. The two match each other remarkably well, actually. And some people say, oh, that demonstrates that global warming is a result of carbon dioxide change. It doesn't actually demonstrate that at all. That is a possible demonstration from that. But also the amount of carbon dioxide in the atmosphere depends very much on the factors that influence temperature, which is why they track so well. But it's also true, of course, we can't model the climates of the past without allowing for the impact of carbon dioxide changes. But look on the right of the diagram, the green line, it's too thick actually. It's because this is the last 200 years or so, since the Industrial Revolution, when the carbon dioxide concentration was about 280 parts per million. It is now about 380 parts per million. You can date my slide by looking where I've put CO2 now on it. And by the end of the century, it's going to be, if we do nothing about it, it's going to be 600 or 700 parts per million. Now that is an enormous rate of change. The carbon dioxide now is greater than it has been for millions of years. And carbon dioxide is a molecule that acts as a thermostat on the planet. We need some of it there. We need some of these greenhouse gases there to give us the climate we have, which is 20 degrees Celsius or so above the temperature it would have without those greenhouse gases. If we didn't have these gases that are helping to keep us warm, then the surface of the Earth would be covered by ice, and we'd be in an igloo, I guess, this morning for this lecture. So we have the climate we have because of these gases. The problem with global warming is we're now changing. We're turning up the thermostat by putting more there, and we're doing it very rapidly, over just over 100 years instead of over thousands of years, which has been a typical rate of change for many of the climate changes of the past. You may say, well, hasn't the climate can change that much in the past, maybe it's going to change that much in the future. Ice ages and all that. We know what triggers ice ages. The main factor is the variation in the Earth's orbit around the Sun. There are various wobbles there, wobbles that are known to astronomers. You can predict them very precisely, and the next ice age is due in about 50,000 years' time, which is beyond the horizon of most politicians. That's 140 years now, we're condensing our time scale. And this is the global average temperature of the whole globe over this period. You will see that the climate is quite variable. And the climate is a very variable thing, which makes it a very exciting thing to study. The period of increasing temperature since 1970 has been persistent and steep, and the reason for that, we are virtually certain, is nearly all due to the increase of carbon dioxide due to fossil fuel burning, and also some due to deforestation. On that slide, 1998 is the warmest year. In fact, 2005 was a warm year, slightly. But in 1998, not only was it then the warmest year on the instrumental record, each of the first 8 months of 1998 was the warmest of that month on record. But when you get 8 ducks in a row, nature's trying to tell you something. So what's going to happen this century? We'll extrapolate that graph I just showed you, which is of course an observational evidence of what's happened so far. We can model the climate, and I won't talk about modelling, computer modelling. Your weather forecast comes to you courtesy of the biggest computer you can find, in which are placed the equations of motion, the basic physics of what goes on in the whole atmosphere and so on. Those equations are integrated numerically to give you a weather forecast. If you want a climate forecast, you have to take the oceans into account, because the ocean and the atmosphere circulations are coupled. You have to take the ice into account, you have to take the land into account, and you have to take the chemistry of the atmosphere into account, and so on. And so you get a very much bigger, more elaborate, sophisticated model. The models used for climate prediction are probably the most sophisticated models of their kind ever produced on a computer. I say sophisticated because there are very elaborate models of, for instance, of galaxies, and astronomers have very elaborate models. But they're not so constrained as the climate models are. The climate models actually have to, first of all, create the present climate. If they can't do that, then they're no good. Astronomers don't have quite the same problem. If you extrapolate using these models, and I can say more if you want to ask questions about it, then we find that the temperature at the end of this century will be between 1.5 and 6 degrees higher than it is at the moment, on average. We say, why such a big variation? Well, we don't really know how much carbon dioxide we're going to emit, so various scenarios are put into that. We also don't know perfectly what the sensitivity of the climate is. So that's also folded into that range of variation. And you will notice that the climate models also produce quite a lot of variability on the way through. You may ask, well, what's a few degrees Celsius? That doesn't seem very large. Remember, this is a global average temperature we're talking about. It's not the temperature in this room, which is probably higher by a few degrees than it was first thing this morning, because your body heat has made it warmer. We're talking of a global average. If you remember the Ice Age diagram, the difference between the end of the middle of an ice age and the warm periods in between is only 5 or 6 degrees in terms of global average temperature. So if you're talking of 2 or 3 degrees, in terms of climate change, that's about half an ice age. And that's an enormous change. And that taking place in 100 years is a very rapid rate of change indeed. And it's more rapid, we're pretty certain that the climate has changed certainly for the last 10,000 years. So let me move on from the basic science to some of the main impacts. And first of all, is sea level rise. Sea level rise because the ocean expands, the water expands as you heat it, so the sea level will rise for that reason. The glaciers are melting around the world, and that's adding to that sea level rise. And the best estimate we have for those two reasons is that the sea level will rise by 40 or 50 centimetres by the end of the century. For you in Cambridge, that could be a bit of a problem. For people to the east of you, near the Fens, it will be a big problem. For people in London, it will be a big problem, but we largely can buy our way out of it with money and other things. It won't be very pleasant. We'll have some problems. So if you go to Bangladesh, there is the 1, 2, 3 and 5 metre continents. The delta regions are sinking anyway because groundwater is being pulled out far faster than it should be, causing the ground to sink. It's very, very fertile land. Lots of people live there because they can grow things. It's a delta region, very inundated, of course, a very complex coastline. And 10 million people live below the 1 metre contour. And where are they going to go? If you go to southern China, there are 25 million people living in a similar circumstance. There are many hundreds of islands in the Indian and Pacific Oceans which will disappear. There's the Nile Delta in Egypt, and even Florida is going to suffer. Quite a lot of Florida will gradually disappear because this sea level rise, you see, we're talking about perhaps half a metre this century, but it's half a metre a century because you've got to warm the whole oceans up. It's only a little bit that you warm the first 100 years, then the next 100 years will expand the next bit of ocean. And so this is half a metre a century for many centuries. And in due course, Florida will half disappear. I don't know if Jeff Bush knows that, but perhaps he does, but he's not bothered. I don't know. But that's just, and I've not mentioned at all, of course, the melting of ice caps. I'll mention that in a minute. Now, in 2003, in Europe, there was a very unusual event, a very unusual heat wave. 20,000 people died in that heat wave. Some people say 35,000 people died. It's hard to know exactly how many people died because of it. But it was 20,000 is a very conservative number. We're talking about the average temperature now for June, July and August. That's a 3-month summer period. And if you plot out the temperatures for that period, for the last 140 years, each of those years will produce a blue line. Until 2003, the warmest year was 1947. 2003 is 5 standard deviations away from the average. If you do a simple analysis of return periods on a summer like 2003, you come up with a period of about 1 million years. It's a nonsense calculation, of course, because that's not what's been happening. It's not a random event. It is an event for which the risk, most of the risk, is due to the fact that the Earth is warming up and that we are burning fossil fuels and we're increasing the greenhouse gases in the atmosphere. And studies have demonstrated that that's the case. It is one of the few events that we know, extreme events that we know in the world, which is so outside the range of natural variability that we're virtually certain that most of the risk of that event was due to human activities. And by 2050, it's likely to be an average year. By 2100, it's likely to be a cool year. I live in West Wales, and people come to Wales for their holidays, and I tell them, well, you must get ready for many more visitors because people won't be going to the Mediterranean. They'll be coming to Wales. Now, that's the Nile running through the Sudan. What's going to happen to water? Water is becoming a very scarce resource, very important resource. It's a shared river, And a lot of people say wars in the world are going to be about water in due course. We've had some wars this year, actually, because of water in Africa, because of the droughts. So what's going to happen to water vapour and water in our globally warmed world? The simple physics is that you get more evaporation from the ocean surface, more water vapour, that gives you more average rainfall. And there is more average rainfall in many parts of the world at the moment, we're measuring it. But there's another very important bit of physics there, and that is that when water vapour condenses in the atmosphere to form clouds, latent heat is released. And that latent heat is the biggest single source of energy for the atmosphere's circulation. So the hydrological cycle will become more intense. It's easy to wave your arms around and say that, but the models, it's all the physics of that is built into the models and their predictions and projections. And the robust result from the models, we don't know exactly where it will all be, are that the rainfall will tend to come down in more intense amounts, hence more floods. It will also, incidentally, tend to cause more droughts, because of the circulation goes higher and the air will become drier, so drier air will become more common. Now, floods and droughts are the biggest disasters the world knows. They cause more misery, more deaths, more economic loss than any other disasters we know. Over the last 25 years, that's been the sort of story about floods and droughts. The number of people affected, the number of people actually dying, and this does not include, incidentally, tropical cyclones. What's going to happen as the carbon dioxide increases? It's been quite hard for the models to really quantify what will happen, quantify the increased risk of floods and droughts. But a number of papers are now out in the literature. The floods work has been done for some time, suggesting that you're going to get an increase in perhaps in a factor of 5 in the extreme floods. Study in Europe has shown it's likely to go up by around a factor of 5 by 2050, which will be about the time when CO2 is very close to doubling, even if it hasn't got there. And the paper that's about to come out in the Journal of Hydrometeorology by some scientists at the Hadley Centre at the Met Office, which is often said to be the best centre of its kind in the world, and it gives a very frightening result. They have studied droughts around the world, and drought you can define rather precisely into extreme droughts or severe droughts or moderate droughts. They've looked at all of those, and they've also tried to see if they can reproduce the amount of land area in the world under drought for the period 1980 to 2000. And during that period, there were about 1% of the world's land area at any one time was under the most extreme drought, as defined by a technical definition. The situation is now that about 2% of the world's land area is under the most extreme drought. And we've seen droughts in Africa, very severe ones this year. For instance, in Australia. By 2050, we're talking of 10 to 12% of the world's land area being under the most severe drought. And when you think of the severity of droughts, they depend very much in their impact on how long the drought is. And the increase in severity and the increase in the amount of land area will be very much come in the context of longer droughts rather than more. Now, if you have a drought for a few months or a drought in one particular year or one season, providing the next season's all right, the population there can, with help, can get over it. But if your drought lasts for 3, 4, 5 years, then what do? They have to go somewhere else because they can't survive where they are. That is, to me, the most devastating statistic I know about global warming and the likelihood of what's going to happen in the future. Because it's going to be devastating for so many, particularly poor countries, but not just poor countries, others in the world too. I must mention the impacts on the ice, because you can read a lot about that in the press. That's just a ship at the North Pole. You can get there in a way you could never get there before. And of course, some people think that's marvellous because it won't be too long before you'll be able to have shipping through the polar regions, which will cut the length of voyages from some parts of the world to others by enormous amounts. Just let me mention Greenland, because Greenland is a bit of an icon, as well as important. And the ice on Greenland, it's glowing in the middle because you're getting a bit more snowfall, and because it's a little warmer. It's an ablating around the edges because it's warm around there, so it's ablating rather fast, and it's much faster than scientists really expected, and it's happening rather quickly, and we can't really predict how long it's going to take. In the IPCC report in 2001, we said that Greenland was likely to start to melt down if the temperature rose by 3 degrees in the region of Iceland, in the region of Greenland, and that's going to happen pretty soon. There is 7 meters of sea level rise in Greenland. It'll take hundreds of years to melt Greenland down, maybe thousands. We don't really know how long it will take to melt down. But people are rather frightened that it's getting faster than they expected. And if it took 700 years, you've got a metre a century, and that's pretty large actually. That would have a very big impact. There are similar concerns about the West Antarctic ice sheet in Antarctica, and the really vulnerable bit of that has 4 meters of sea level rise in it, and that's so that's a serious issue too. If any of you have seen the film The Day After Tomorrow, you will know about this. The science on which that was predicated was changes in the Gulf Stream, which I won't explain, which might come about because of the way in which the hydrological cycle is going to change the way in which the ocean operates. I just put up that as an indicator of something that might happen. I tend not in my talks on global warming concentrate on these more unknown things, but it's when you think that we are beginning to change things on Earth which we don't know about, that's very worrying. I used to argue years ago, when I was concerned with the ozone layer and so on, and the science of that in the 1970s, that the Earth was, the atmosphere was a pretty robust place. That when we were talking of parts per trillion of chemical compounds in the atmosphere, that really wasn't going to make a big impact because the atmosphere was so big and so huge and so robust, one believed. I was shaken, as well other scientists concerned with the ozone layer, when the ozone hole was discovered in 1985, when virtually the whole of the ozone layer over Antarctica at the end of the polar night had disappeared. And we didn't understand the reason for that because it seemed highly improbable that there could be reasons for that. Well, there are scientific reasons for that. And that was a demonstration, I think, to the scientific world, climate community and the scientific community, that the Earth is more fragile than you might think. Or else you could say we are more vicious than you might think. And there are things that we can now do. And the ozone layer story, of course, is another story, and that's beginning to heal, but it will take 100 years to heal. There are long time constants associated with changes in the atmosphere. There are long time constants associated with global warming. So we have to remember the fragility of the atmosphere. Now, so that's just a summary of what I've told you so far. Well, how sure are we of the science? Let me say a bit about the IPCC, because it was a wonderful experience to take part in that activity. It was a body that was formed in 1988, the United Nations body, formed by 2 United Nations bodies, the World Meteorological Organization, which joins the Met Services of the world together, and the United Nations Environment Programme. And in 1988, the Intergovernmental Panel on Climate Change was set up in order to carry out really good, accurate, honest assessments of climate change. And I became chairman of the scientific assessment, and I stayed as chairman of that assessment until 2002, so I had 14 years of working with the IPCC, and that was, they were great years, because it was clear to us at the start that if we were just a bunch of, a dozen scientists who got together to carry out an assessment, that was going to be no good at all, because people don't read things like that, they put them in the waste paper basket. And the Intergovernmental Panel is an intergovernmental body, so it's owned by government. And that was a more important thing than we ever realised at the start, because it meant that our reports actually went through the hoop of persuading governments that we'd done a good job. And then they were owned by governments, because governments had helped to set up the final policymaker summaries. The thing we did realise from the start was that we really needed to take account of all the best scientists in the world we could find. We need to use them. A world thing involves all countries by its nature. So let's try and involve all the scientists we can find in order that the scientific community in all countries actually owns it. So that's what we did. And those show you the 4 volumes of our 2001 report. They are thick volumes. They are A4, 1,000 pages each or thereabouts, with many thousands of references. I think the largest single reviews, or the most elaborate reviews that have taken place on any scientific topic ever, especially when you consider the uncertainties associated with climate change. So how did we come to some agreement about it? Well, we had our basic task was to distinguish between the things we knew, the things we were pretty sure about, and the things we didn't know. And to try to tell the world the things we were pretty sure about, and then also all the various possibilities about the things we didn't know too well. And that was a very important distinction to make. We had meetings, big meetings, with many hundreds of scientists present. We had big arguments, we had great debates. But under the discipline of science, despite people coming from very different agendas, personal agendas, nobody was allowed to use his ego to say, I'm the greatest man in the world and this must be right, because that didn't wash when you had such a big body of people there. We had to share the disciplines, which were very important, because it's not just physics and mathematics, it's also chemistry and biology, and all those things had to come in. And we were able to produce reports which came to a consensus, came essentially to a consensus about what we were saying. And right at the beginning, I could say that when we had our first meetings in 1989, I can remember the first one, which happened in Union Court near Oxford. We had about 100 scientists there, and a significant part of that body, probably half of them, said, we're scientists, we're honest people, there's nothing we can say, it's too uncertain. We can't stick our necks out and say anything on this issue. We'd rather just keep our heads below the parapet. And I and others tried to argue that that wasn't what we were there to do. And I was at the Met Office at the time. And I said, well, every day we give out forecasts. And if our forecaster gets on the television at night and says, I'm very sorry, I can't give you a forecast tonight because I'm so uncertain, then he's not doing his job. What he has to do is to give his best story and say, what is most likely to happen tomorrow is the following. He may be wrong, but it's better information than to give no information at all. And the public know about the uncertainty of weather forecasts, so you don't have to explain that to them. But we had to give our best story and also explain, as well as we could, what the uncertainties were and quantify those as well as we could. And that's what we did in these documents. And the summary for policymakers, which is the most exposed part of the reports, 10 pages long or so, had to be agreed sentence by sentence in meetings which had, there's the one which, the opening of the one in Shanghai for the last report, when government delegates could question the scientists, could propose changes to the document if they felt it was incorrect, but only incorrect in a scientific way. No political arguments were allowed. They had to argue on a scientific basis, and the documents improved enormously during those meetings, because they would say, well, you've said this here and you've said that there, but scientists, it doesn't agree. What do you really believe? Or we don't understand this, or this isn't politically very relevant, or what about this issue, which is politically very relevant? Please tell us about that. So the documents actually got a lot better during this remarkable process, which was a very tough process indeed, I might tell you. So that's what happened in the IPCC. A lot of rubbish has been talked about the IPCC. We've had a lot of enemies, and I'll mention some of that in a minute. But in June of last year, 2005, before the G8 conference, the 11 national scientific academies and the 11 largest countries in the world, the G8 countries, plus India, China and Brazil, put out a 2-page statement signed by all their presidents to explain that, it's written down there, that climate change is happening. It's a very serious issue. Countries really have to take it seriously and take urgent action about it. And incidentally, the IPCC is a believable document. It's a document you should really take some notice of, because that's where the consensus has occurred. That's a very powerful document indeed, in principle, because they're not environmental scientists, they're not even climate scientists. They are the world scientific communities at the highest possible level from the major countries of the world. And if the world will not listen to that level of scientific agreement and to that scientific message, then we've got big problems. And we do have big problems because a White House aide commented as it came out, we have our own scientific advice. And well, why is there such a debate going on in the United States? I could go on for some time about that, and I won't do that. But if you want to know more about it, George Monbiot is publishing very soon a book called Heat. But within that, he has a couple of chapters on this. He's researched it rather thoroughly, how this has occurred. And it makes very interesting reading. It's a good book, incidentally. It has a lot of information about all sorts of energy sources and problems. You should get hold of it and use it. But in 1992, when the Climate Convention was signed in Rio at the Earth Summit, and it was signed by all nations of the world, President Bush Sr. signed for the United States. And the Senate afterwards unanimously ratified it. And that, it said, that global warming was happening, or it was very probably happening at that time because the observational evidence wasn't so strong. And it also said that developed nations should aim to reduce their emissions so that they came down to 1990 levels by the year 2000. These very, very strong, it was not mandatory, it was just saying this is what we believe should happen. That was agreed in 1992. That was then followed almost immediately by a massive misinformation campaign set up, led by Exxon in the United States. They put tens of millions of dollars. They hired top lawyers to spread misinformation, especially in Washington. They got hold of all the senators and all the congressmen. They got their own man in the White House in the end too. And they made sure that the whole thing was made so uncertain and so impossible that people believed it wasn't really happening. An incredible misinformation campaign. They tried hard to destroy the IPCC. They tried to discredit us in all sorts of ways. Some of them were valid argument in a way. Some of it was completely below the belt, and I could tell you stories of the lies that were spread around to try to discredit us and to try to discredit me in particular. And it's still going on. Well, what has to be done about climate change? And what are the things we can do? The Climate Convention, signed in 1992, has an objective to stabilise carbon dioxide in the atmosphere at some level. If we just carry on increasing emissions, of course, we won't get stabilisation of concentration. Carbon carbon dioxide lives for a long time, 100 years or so in the atmosphere, typical number. And there has to be a choice made as to what level we stabilise at. We don't ruin the world's economies by turning to carbon dioxide at tap-off today, because that wouldn't solve the problem. And we have to do it in a sensible, responsible way. What does that actually mean in real terms? We are currently putting out about 7 billion tonnes of carbon a year from fossil fuel burning. If we carry on with business as usual, we will put out 20 billion tonnes by the end of the century. The World Energy Council, which joins together the world's energy industries, they published in the 1990s some very good material, including the green curve, which says we could begin to reduce these emissions, and we could follow that curve, which is the ecologically driven curve. And if we follow that curve, we will stabilise concentration at around 450 parts per million. And that's the sort of thing we have to plan to do. They explained how it could be done, but said it's going to be very hard to do it politically. The international challenge is represented in that diagram. Those are the per capita emissions from different countries or groups of countries in the world. The red ones are developed countries, the green ones are developing countries. The United States is putting out about 6 tonnes per capita. In Europe, we're putting out about 2 or 3 tonnes per capita. China is putting out 0.7, 0.8 of a tonne per capita, and India about a quarter of a tonne. If we now think of the challenge of an international agreement to say we have to cut emissions to this line, this dotted line, has to go down with time. That's the average. So an average has to go down with time. And we have to do it in a way which is fair to those countries of the world. Fair and honest. So if I can talk about the moral imperative, I'm sure I should have some other word after David's talk this morning. I'm not allowed to use the word moral because people don't like that, but I do use it. And I say that demonstrates, that last slide demonstrates the moral imperative. We in the West have used cheap energy from fossil fuels for a long time. We've got very wealthy that way, and our wealth has very much depended on that fossil fuel energy. We didn't know what damage it was causing, now we know. The developing world want to grow. There's lots of coal around in India and China and elsewhere. They want to use those fossil fuels in order to grow their economies like we did. And you might say, well, they have every right to do so. The imperative on the developed world to take action is very strong indeed. That was recognised in the Climate Convention, signed in 1992, which says that developed countries should take the lead. And it explains why, because we benefited from it so much so far. And we should take the lead in doing it. So when countries, and I'm sorry to keep going on with the US, but when they pass a resolution in their housing, in Congress, which says we will not take action unless India and China do, that goes right against the Climate Convention, and it's the moral low ground, it is not the moral high ground. There's some rumours going around on the internet at the moment that within a week or so President Bush is going to do a U-turn on global warming. Whether those have any foundation or not, I'm not privy to. I hope that he might do that and recognise this moral imperative, which is clearly built into not just a religious response or Christian response. I've talked to many audiences and used this slide and so on, and they really pick up that moral response. I was at a meeting in Chatham House not too long ago. Other people were talking about this moral imperative, maybe not in those words, but that's what they meant. It's a very strong moral pressure on us in the developed world to recognise the result of our profligate use of the world's resources. Let me just tell you what it means in terms of, I've carbon dioxide stabilisation. Just a bit of science, because people should know this. The curves there are stabilising carbon dioxide concentration at 500 parts per million. That's what we have to do to emissions in order to get that stabilisation. The emissions have to start to come down pretty soon and get to rather low levels by 2100. The World International Energy Association, which is the body that regulates the world energy industry and describes it and so on, their data is in the red and the blue bits. They show that the world is just going very rapidly increasing emissions. Many parts of the developed world haven't started to cut down. The United States will be 30% higher by 2010 than they were in 1990, because they haven't even begun to try. And the second scenario there, also from the IEA, saying, well, if we really took some action of the kind that people are talking about, we might get down to that. But that's not good enough. We have to do something very much better than that. And what the sort of thing we need to do, and I've tried to draw it here, is that stabilises at 500 parts per million again, and that cuts developed countries' emissions by 60% by 2050, which is Tony Blair, the number Tony Blair talks about for the UK. And it increases developing countries' emissions by 40% by 2050. And I'm sure that's nothing like enough for the average developing country. But that demonstrates to you the sort of action that we need to take, and we need to get on with it. And those things are possible. Now, some people say, well, let's wait and see. You know, we've got time, so why don't we wait and see? It's very urgent for three reasons. The first is scientific, and that is that if we turned off the CO2 tomorrow, the climate would change for 30 or 40 years because the oceans take time to heat up. We haven't seen anything like what we've already committed to by what we've done so far. Secondly, we're building power stations all around the world. China is building a gigawatt power station every 5 days, from coal. And we're building things that we're going to be ashamed of in 20 or 30 years and want to change. And that's very uneconomic, because it means we're not planning in a sensible manner. And the third reason is political, because countries like India and China, they know about climate change, they're going to suffer from it, they know that. But they will follow, not lead. I was at a meeting not too long ago when a Chinese delegate, a Chinese energy expert, got up and said, don't you expect us in China to take the first action and to do things? When you do things, we will do them. We will follow you. Which reminds me of, I remember being by one of the motorways in Beijing now, which is lots of motor cars. And I said to the Chinese person I was with, I said, why don't you go in for little cars in China? There's so many of you. You know, why don't you go in for little cars? He said, do you have little cars? You have big cars. When you have little cars, we will have little cars. They will follow, not lead, and we should be taking the lead. We have an enormous responsibility in our wealthy part of the world to take the lead. That's an estimate done by the UK Treasury of the cost of cutting our emissions by 60% by 2050. They estimate we might lose 6 months economic growth over 50 years. It can be done. And these are not environmentalists, they're not Greenpeace people, they're people who work for HM Treasury. So you could say they have no biases of that sort of kind. What do you know about Kyoto Protocol now? That's something which, it's a remarkable document, it's a remarkable agreement. Some countries of the world have actually got together and agreed to do things. Very complex agreement, said to be the most complex international agreement around. It sets up mechanisms, it sets up trading between different countries in carbon dioxide, and people love trading. It is full of holes, it is leaky all over, but it's beginning to operate. And that's, we should be very pleased about. People criticise it because they say it's leaky, it's not doing much, and all those things. It is setting the way forward, which we have to follow. I was going to talk a bit about sustainable energy, but maybe I should move on to the last part of my talk. We need to be more efficient. There's the possibility of sequestering carbon underground, pumping it down into rocks, taking it from coal-fired power stations or other power stations, taking that carbon dioxide, and it'll cost a bit of money, but the cost of doing it is not that large. The European Union is working with China on a demonstration plant in China, and other people in the world. BP is building one up in the northeast somewhere. So that's beginning to happen, and that will make an enormous difference. Energy improvements are possible all over the way, in many places. Let me show you that because it illustrates the problem. It's a map of Aberdeen, taken in the infrared. Red buildings are hot buildings, not well insulated. Blue buildings are cold buildings, okay, well insulated. In the middle of Aberdeen, you have a lot of old buildings which are pretty poor, actually. But look at some of the buildings on the outskirts. We have these new housing estates, and we in the UK are just not building them properly. They all should have combined heat and power too, because that doubles the efficiency. And are we doing that? No. That's another infrared picture. And that's the pumping down into rocks. That's my garage at home with 4 kilowatts of PV cells on the roof and a Toyota Prius in the garage, which is a hybrid car, showing you the benefits of technology. Technology is out there, it has to be done on a big scale, the prices have to come down, but the possibilities are there, and we need to take it seriously. And these are some of the possible ways in which we can reduce energy, and I can talk more about that if I had time, but I want to talk a bit about strategy. There is no one solution. And there are people around out saying, oh, nuclear is the answer, wind is the answer. There are all sorts of answers, possible answers. And if you have a boat and you say it has a motor, it has an engine, it's driven by technology. It has a propeller, I call that the market. And some people think, well, it's just technology in the market, and if you get in a boat and all you've got is an engine and a propeller, where do you go? You might go anywhere. You don't desperately need to think about what you're doing, you need a strategy. And something I think is important, and this is society response and so on, we need a strategy which will take account of social factors, political factors, people factors, as well as other things, the long term and not the short term. Take account of allow economics to help you on your way in getting the policies right and all those sorts of things. One thing on the social side, which I think is terribly important, is we need to differentiate between big sources, which might be needed for cities, and local sources, which are essential in the country. China is losing population at an enormous rate, and they're very worried about it, from the rural areas to the cities, and they're talking of mega cities, 50 million people by 2030, if you can imagine that. How do you keep people in the country? You provide the technology and the energy and all the other things they need in the country, and you can do that. That's a quote from Gordon Brown on the economy and the environment. And one way of getting energy, a poor way of getting energy, is from biomass. In Austria, they're going full tilt to get most of their energy from biomass. We're getting very little in this country from biomass and waste. I'm a trustee of a charity called the Shell Foundation, which is, Shell has put $500 million into the foundation, and we're supporting sustainable energy in the third world, for the poorest people in the world. We have all sorts of projects, but there are enormous quantities of rice store in China. There's a plant being built in a village which provides gas, a gasification plant from rice store. There are 1 million villages in China that could do the same thing. In India, they have all these public loos, and then they provide energy. You can light these cities from the loos. and so on. There's lots of possibilities, waste material around the world. In fact, I was given a statistic the other day by the last chairman of Shell, who said that if you took all the waste product, the biological type of bio-waste products in the United States, and you turned all that into energy, because it has energy within it, it may be hard to do it with some of it, but if you just a very round number, you could actually fuel the whole of the American transportation system, land, sea and air, from it. So the potential for doing that is very large. Politicians hate it because, you know, they want to open a big thing, you know, a big power station or something. And we should really be pursuing some of these other things very hard. That's a local solar energy supply. Attitudes to climate change. I've talked a bit about denial. That denial is still there. There's another attitude which is becoming a little common, and people like Jim Lovelock have unfortunately tried to fuel this of it. He talks about as getting beyond the point of no return. And that uses the illustration of supposing you're above the Niagara Falls in a loincloth, and you don't realise you're there, but all of a sudden you go down the abyss. He came and stayed with us for a day or two a few months ago. He's a lovely man, 87. He's done some great science, and he's a great thinker. He's a great writer too. But I took him to task a bit over this. Said, if you put that over, what impact does it have? Because it's not like that. We may be entering a region of very severe rapids and getting more severe all the time. But we can do something about it. We can actually try and navigate. We can try and build structures that will help us through those rapids. We can even do something about the rapids themselves. But people love that message, you see, that we can do nothing, or not much we can do. Because they say, oh, that's all right then. Nothing I can do. And it's the same message to people as the denial message. So we need a real determination to do. And I believe that's very important. I'd like to have another 3-4 minutes. No. Let me just talk about, I spent a bit of time in the last few years with the American evangelicals, the group of the religious right, well, all Republicans, 500% supporters of George Bush, and trying to talk to them about the problem of caring for creation and the science of climate change. I won't go into the whole story, but because it's quite a good story, but some of us, 30 of us met in Sandy Cove in Maryland in 2004. And that sort of Christian community has not been very concerned about the environment at all. They felt it wasn't important, the earth might disappear anyway, what were we worrying about, why didn't we just get on and use the earth for our own benefit, and all this stuff about, biodiversity loss, they were bothered about, and all this stuff about looking after, caring for creation, or even caring for the poor was not at all dominant in their minds. They felt the great way to care for them is to allow the American economy to be really robust, because that gives the poor resources of a kind they really need, and so on. But we had a very good talk from a man called Howard Schneider, who's a theologian from Philadelphia, who talked about the biblical need to care for creation. And many of the people there had not really thought about this problem at all before. And we were there to try and make some statement at the end, or people who did care about the issue wanted people to make a statement. And we struggled with that because they said, well, we don't know enough to make a statement. How can we possibly say anything about the environment because we don't know about it? So what they did was to write a covenant instead, because some fishermen in Chesapeake Bay, and that's a good story actually, had come round to making a covenant to care for the pollution in Chesapeake Bay. And some of these fishermen, not articulate people, but terribly committed people, had spoken to us at lunchtime on the middle day of the conference. They said, why don't we write a covenant like those fishermen did? So they wrote a covenant, and here are the words of it. And they recognise that caring for creation is important. And this is the covenant that was written. And they feel called of God to covenant together to move the work of creation care ahead in a variety of ways. And they said that clearly this is an important part of our Christian discipleship. They said we've got to learn about it. So we will use the most trustworthy resources we can find to find out about it. And we will try and share our knowledge with others in the community, in the evangelical community. And within 12 months, we will write a statement on climate change. They didn't quite make the 12 months, in fact, but in February of this year, they did in fact 90 leaders from that community. And that community as a whole represents something like 25% of the American population. They did in fact write a statement which was published in the New York Times. They're well publicised, it's been well known, saying that climate change is a big issue, we really need to take it seriously. And even leaders like Rick Warren actually signed it, which was quite a coup, it was thought, for the people organising it, because he's a very well-known Christian in the United States. Second best-known Christian to Billy Graham, they said. So and that's having an impact. And it's interesting to see the way in which they moved along from a concern for honesty and truth and all those things. Talking of stewardship, I often, when talking about the way we do science, the way we apply science, and global warming is a very messy subject. There's an enormous amount of data out there. If you have an agenda, you can prove anything by selecting your data. Not all parts of the world are warming. Some parts are cooling, so you find those and say it's cooling. Not all, a few glaciers are not receding. So you find those to use your illustration. In fact, you can collect data which makes it look as if all these, the science we talked about in the IPCC is wrong. What we had to do in the IPCC was to look at the whole thing. We had to try and balance the whole of the scientific data in front of us and say what is the message which is really there. And so that's why I include holism there. We need to look at the whole thing. We need to be very honest and not come with any agenda of any kind. And we need to be humble, because we have to recognise that we don't know it all, that we may have got it wrong in some regards, we may have got it all wrong, conceivably. But so we have to be humble about the way we talk about it. We also have to be humble in the way we apply our technology so that we don't ruin people in the process. We imagine that we might have technological solutions, but are they really good solutions? The third world is littered with solutions to environmental problems that haven't worked and have been big problems of their own. So 3 words to remember, the 3 H's in our looking for stewardship. Talking of agendas, just one other story. I don't know if you've seen Michael Crichton's book, State of Fear, which is a book, it's a James Bond sort of thriller. He's an American writer, and he was very keen to get over the anti-science of climate change. And so he weaves it into his thriller, because there's a court case going on. And the arguments used by the lawyers, and he produces them all. All this is the objections to the fact that climate change isn't happening, and the green groups are blowing it all up. And his whole story is to show the intrigue and the efforts made by green groups using quite incorrect methods, using terrorist methods actually to get their message over. So it's a fun book to read. He finishes up at the end. So I'll tell you some facts about global warming. Here they are. And they're a mixture of facts. Some of them aren't too bad, and a lot of them are very negative. And they're on a few pages. They're just statements. And the last statement, I think, is absolutely revealing. He says, everybody has an agenda but me. Finally, reasons for optimism. A lot of people say to me, or used to say to me, they don't say it so often now, you're wasting your time all, because the world will never agree, will never come to closure on this climate change issue. So why don't you go and do something else? And I said, well, I feel optimistic for 3 reasons. One is I've worked with the world scientific community, which has been a wonderful experience, recognising that under the honest discipline of science, whatever your gender, whatever your religion, whatever your country, it is possible to come to agreement about what the science is saying and roughly what needs to be done. I know the technology is available, but we have to get on to use it, but again, in ways that are consistent with my 3 H's. And then people say, well, why on earth bring God into it? And what I say there, and I try to go over a point of faith without explaining it too explicitly, but to say, as human beings, we need to be fulfilled, and being fulfilled doesn't just mean pursuing economic goals, pursuing money, pursuing materialist ends, which most of us in the West are tending to do, whether we're Christians or not. But we desperately need moral and spiritual goals to go for our fulfillment as human beings. And I believe that very strongly. And here is an issue, which is a world issue which affects everybody in the world. It's an issue where a great deal needs to be done, and nations need to get together in a way they've never got together before. They need to agree in ways that they've never agreed before. They need to share in ways that we've never shared before. We're quite good in sharing with our family or sharing in our countries with social programs, all those things. Internationally, we're rotten at it. The movement of money in the world is still from the poor to the rich. So we need to learn to share. Lots of things we need to learn to do. And as if we could all begin to be more honest and more holistic and more humble in approaching a problem of this kind, then we might make progress a bit faster. And there's my fragile world I see from the room. Thank you very much.
Thank you very much, Sir John. There's plenty of time now for questions. All sorts of issues raised there. So, the floor is yours. Yeah.
Hi. You're quite critical of the doom and gloom attitude towards... Hi. Can you hear me now? Yeah, quite critical of the doom and gloom attitude towards global warming, particularly Jim Lovelock, because then it fosters this attitude of not doing anything about global warming. But Jim's a pretty good scientist. Is he, in fact, from a scientific point of view, right?
Shall I just repeat the question? Is Jim Lovelock right in his doom and gloom or not?
Well, it depends what you mean by right. He has a very interesting, and he has the widest, scientific appreciation, I think, of all the disciplines involved, the biology and the ecology and all those things. A wider knowledge of those things than almost anybody I know. Of a broad kind, that is. And he's also an honest person. He's trying to, put out what is a possible scenario. In fact, he said to me when he was with me, he says, supposing by the end of the century, there are so many parts of the world where people can't live, and billions of people won't be living anymore. Supposing a few of us have to go and live in near the North Pole, or the South Pole, what would you think of that as a Christian? As a possible scenario. Interesting question. But that is an extreme viewpoint. And I think if you end up being debates with him and other scientists too, if you look at what we know and the balance on it, the climate system is very complex, and more complex than Jim Lovelock tends to generate very simplistic models. There's Daisy word model, for instance, and he comes up with very simple models with feedbacks, and the feedbacks become very positive and things happen. And I don't do rubbish that. I think it's very important in science, but the likelihood of it happening like that, I think, is very low. It's possible, but it's very low, and we have to look at more. You know, in the IPCC, we tried to be very conservative in our view. We didn't over-egg anything. We didn't, and we've shown, these events have shown us to be conservative, and we need to tell people the conservative story and say, let's get on with it and do what we can. And there are lots of things we can do to stop it getting really worse. It may get worse than we really want it to. It's going to get worse than we want it to. But there are things we can do about it. If we don't do anything about it, it really will get worse in a very big way.
First head, okay.
Thank you. You said at the beginning of your talk about different greenhouse gases, CO2 and methane, and also mentioned water vapour, as contributing to this warming effect. Quite a lot of the focus is still upon carbon dioxide, and it seems to me that that's because, in a way, we can do something about it in terms of transport and building and industry. And at the transport level, it goes to the individual who has a car, and who can choose the level of CO2 emission that he or she wishes from the particular engine. But what about methane and the proportion of methane that is being produced, sometimes not by human beings, but by natural processes? Is there a way that we can do something to monitor that and actually check that, and also perhaps take some of the heat off CO2, if you like, and then go towards that methane?
Well, methane is very interesting. It's about 20% or 25% of the global warming effect at the moment is due to methane. But methane is the growth of methane is gone by a factor of 2 since the pre-industrial period, largely because of the sources of the human attacked sources of methane are cattle and other animals that produce a lot from both ends. Rice paddy fields and the like, leakage from oil wells and so on, and things of this kind. I tell you, the last decade or so, the growth of methane is slow a lot. We're not too sure of the reason for that. One reason in the 90s was thought to be, and almost certainly was, that the Russian economy collapsed, and they had pipelines in Siberia that were said to leak at least 50% of the methane that was in them. And once you close those down, that stopped that leakage. There are ways of trying to reduce it from the sources I talked about. People are actually worrying and concerned about how they feed animals, or genetically modify animals so they produce less. I remember seeing in New Zealand an experiment with sheep. Actually, they had bags on both ends and were measuring it and trying to reduce it. You can do a lot in the rice paddy fields actually by not paddling around at the wrong time, not stirring the mud and so on, and that cuts it by quite a big factor, a significant factor actually. You can do a lot about waste dumps which leak methane. You can collect the methane and burn it and use it to create power. And that's being done on a bigger basis. You can, and then of course this methane that also comes from forest burning, and we've got to stop destroying the forests at the rate we're doing it. So the methane amount is beginning to level off. But there is also a worry, and we should have heard about in the last few days, and that is that there are enormous quantities of methane as locked within the tundra, and we're in the seabed. And if we destroy the tundra, some of that methane will get released. Now, the estimates vary enormously as to what the possibilities or probabilities are there. But that is a significant one for the future, as ourselves. We're going to get substantial releases of methane, which could be a problem. But methane lives in the atmosphere about 10 years. It's a shorter lifetime than CO2. But it's a much more powerful greenhouse gas.
Yeah, I just want your personal opinion. Now, assuming a fellow Christian comes to you with a preconceived idea that God is loving, He is caring, and is in control of everything that He has created. what would be your response?
Can you speak up a little bit?
Okay,
A little depth,
if a fellow Christian came to you and said that God is loving and he cares for what he's created, what would your response be? The implication is that he will take care that nothing will destroy humanity.
So with regard to global warming,
With regard to global warming.
Well, I mean, you can, as a Christian, and a believer in God, I believe that God has overall control in a real sense. But I also believe that he's delegated to us stewardship of the world and creation. And when you see things happening because of what we're doing wrong, then I can't blame God for it. Nor can I expect God to solve it. I mean, in the New Testament, you read about people who said, well, God's in control, so we can sin as much as we like. We can do as many wrong things as we please, because God will look after the result. But that's a nonsense, you see, from a Christian perspective, or any religious perspective, to argue in what was called the antinomian way, that we can do whatever wrong we like. We've got to stop doing wrong. We've got to stop sinning, as the Bishop of London told us a few weeks ago. Not to care for the earth is a sin. And we've got to stop sinning and try to care for it much more responsibly. Because God expects us to do that. And God will, in his great purposes which are way outside our understanding, he will use what we do for the benefit of his kingdom, whatever.
Regarding that CO2 capture and then the injection or sequestration, for example, into the reservoir and the air where oil or gases are depleted these days.
Can you, again, I'm sorry, I'm a little deaf.
Okay, it's about CO2 sequestration
Yes.
into reservoirs where oil or gas has been
Yes.
removed.
Yes.
That approach in which CO2 can be somehow reduced in a way that can be utilized for the moment to re-inject that CO2, for example, into the empty reservoir down there. So while in a few years to come, those rigs might be moved somewhere else. So I guess CO2 injection in underground
It's one we have to learn a great deal about, and the possibilities seem very important. And there seems to be enough possible places, and Bob knows more about this than I do.
I'm doing research on that.
Enough possible places to put it in the rocks and elsewhere that would certainly last for quite a long time. There have also been proposals that we might just pump it into the ocean, because it's, the pressures at the bottom of the ocean. It would be liquid, and it would stay there, so we hope. And other places, people have also suggested it might have enormous spheres of frozen carbon dioxide, which you just keep frozen. And there are ideas of this kind. We've got to look at all those possibilities. I think putting it into the ocean we're not going to do that for a long time. That seems a bit too dangerous, really. I'd hate to be in a boat on the surface at a time when a bubble suddenly came up from down below. But finding places to put it is obviously important. And we may in the end, of course. The problem may be so important, so difficult, that we may be actually creating stations where we're taking CO2 out of the atmosphere, without it coming from fossil fuels, but trying to reduce the carbon dioxide content of the atmosphere by artificial means. I mean, it's a possible scenario for the future, but that would be very expensive to do, but it might be worth it if the damage becomes so great.
Perhaps I can just add two things from a technical point of view. One is that we don't know whether it can be done because there are complicated chemical reactions, and if you replace oil with carbon dioxide, it may react with the calcite in the rocks and come up the porosity anyway. So we don't know that yet. Second thing is I'm sure it's not a silver bullet, just as nuclear energy is not a silver bullet. It may be very dangerous. Some people may remember a few years ago in Cameroon when Lake Nyos overturned. That was a volcanic lake with carbon dioxide pooled at the bottom. It overturned, the carbon dioxide flowed down the valley and it killed all the livestock and several hundred people, just like that. And then it flowed away. It was only there for minutes, but it killed hundreds of people. If you had a leak from one of these sequestration facilities, you could kill thousands of people. So it's something we should investigate, but it's not an automatic solution to everything. I think, which is true of many of these issues, isn't it? It's true of nuclear energy, it's true of burning biomass.
We've got to look at all the possibilities and weigh them up and try to be, very, very responsible about it, the way in which we look at any of them. But nuclear is often talked about as a thing. I gather you talked about it last night, but, and that is an option which we should look at hard. I agree with John Governor. I don't see it as a long-term solution because of the danger of proliferation of nuclear material into the wrong hands. But we do have in this country and in America and Russia and elsewhere in the world, there are large amounts of plutonium which are there created for military purposes, which are no longer needed, if you can use that expression about them, or no longer allowed to have, and they're being stored away somewhere. We could use that material, we could degrade it in power stations, it would no longer be possible to make it into bombs. And that would be a good thing to do, and we'll get us energy in the process. And I think we should be doing that in this country and in other countries that have it as a start, without committing ourselves to a bigger long-term program. But as a short-term program, I think it's a very good thing to do.
Any more questions? Is there anybody else just before we come back? Dennis, did you want to say something? And then
Yeah,
we'll
I
come
just
back
have a
to
question, which is, we were thinking a lot about the moral imperative in terms of government action, in terms of policy about building houses and so forth. And of course the moral imperative applies to the individual, and when we had the Toyota Prius and so forth, So now, I wonder if you have any reflections about how to get that message across. I think sometimes the sense of I can't do anything becomes strongest when people sort of see some of those data and think, well, it's the government's job to build better houses and to, put insulation in the walls, and we live in this house. I just read actually a section out of Heat in The Guardian, which was published, I think, today or yesterday. And, he makes this point that, the author makes the point, he's living in a house where they moved deliberately for environmental reasons, and only defined, it's hopeless in terms of heat loss and so on. So this can engender a sense of despair, or I can't do anything about it, and literally that is the case. So how do we, in terms of the moral imperative, or how important do you think it is to get that across to the individual consumer, and the houses? I mean, to what extent should we go on at people, if you like, and say, get on your bike and get a more expensive hybrid car, when they are more expensive, I think, and so forth. Do you feel confident that that's going to achieve something, and will it make a difference?
I think that's a very important point, Dennis, which I haven't mentioned much of. The responsibility of the individual is very important for us to pick up, because none of us can say there's nothing I can do, because I can do so little. I had a slide which I often use, which is from Edmund Burke, 200 years ago, who said, "No one made a greater mistake than he who did nothing, because he could do so little." And it should be a T-shirt, on every environmental T-shirt. The fact that we can all do something, because in the end, it's up to all of us to do it wherever we can. And none of us can say, "I'm so small, I can't do it." And so the responsibility comes home to all of us, including me. The Prius, incidentally, was second-hand. I haven't bought the other one. That's too expensive.
But so the panels are not taken away, I'm sure. Not yet, are they?
So the panels are not yet. But there are lots of things we can do. And we can make sure our lighting, for instance, is... We don't have too much of it. We turn lights off, for instance. And we also buy the artificial bulbs and so on. We can make sure our homes are insulated. We should make sure they're not too warm. We can buy green electricity, so that all your electricity is actually non-fossil fuel. That's possible to do. There are people who will sell you. There are electrons that are guaranteed not to have any fossil fuel connection. And those are important things to do. You can pay if you fly anywhere and feel you have to fly somewhere, then you can buy an indulgence. You can pay the offset of that by paying for offsetting that carbon somewhere else. You can do that for your motor car. You can do it for lots of things. So there's a great deal of things that all of us can do in the way you shop, actually, too. You don't find things that come from the far parts of the world that use a lot of transport energy. And we need more information, actually. We should have, everything should be labelled with energy content. It would be very helpful if somehow that could be organised, so that we all try and shop very sensibly, because an awful lot of what we buy has used a lot of energy to provide it. And we all need this information, but even without that information, we can still do a lot by common sense and by trying to, and the way we use waste, the way waste is recycled is important. Often people make a lot of the fact that some of it's wasted or some of it's not very efficient or not very useful, but as a general principle, to recycle waste or not to generate waste is a very important principle. We can all try and follow these principles, and we have to try and spread that information around as well as we can. A lot of bodies trying to do that, organisations trying to do that. There are leaflets you can get. The best I know is a little leaflet by Tearfund, actually, called Tomorrow Too, which is a great little leaflet. It's telling you what you can, what you might be able to do to really try to help to solve this problem.
The Tearfund leaflet is free off the Tearfund web, I should say. You can download it. Dick Cheney famously said no American will ever have to wear a sweater. And there's a cultural change, isn't there, as well?
Sure.
Yeah. Yes. Shall we take a last question?
Thank you.
Oh, did you have one?
Yeah, well,
well, we'll take two last questions, in whichever order you decide. Why don't you carry on?
Thank you. Clearly following your point about what can we do on the kind of individual level, and I think it's very important to conscientise us as individuals in the small communities. So like churches, I'm involved in the church and I can do that. And that's great, but there is such a gap, it seems to me, between the sort of individual doing the good, or even a small community doing the good, and even the networks of small communities doing the good, and the political will and the political decision to actually make real changes, which actually force people to do things. And when I think about the situation in China, and the way that they have a very rapid industrialisation going on there, it just doesn't need to be able to stop. What we do at a small level, and what they do at the macro level, we do on the micro level, it just makes me wonder a little bit about just the quantitative side of that are we really able to do anything very influential, for the atmosphere of this world?
I mean, we do what we can in practical ways. We also, what government needs above all else, government has to stop being so timid. And in order to stop government being timid, we have to give government the confidence to do much bigger things. And that means that we all have to use our democratic power to influence government and to let them know that there is a lot of us around who really want something to happen. That's beginning to happen, and getting this thing over is not easy. But we do have some leverage, as people, and we have leverage which is on governments, and governments have to learn to do these things. And then we also have to use our leverage, because what we do in the West will influence what China does, very clearly. And the Chinese government is very well aware. They have a very good climate research government institute in China, modelled on the Hadley Centre in the UK. I know it well. They know about climate change in China. They know it's going to hit them with floods and droughts and storms and all sorts of awful things, and sea level rise. They know about it. They're aware of that. They want to do things about it, and to some extent they're doing things about it. They have quite a, of course, a dissected society in the way they operate, but it's what we do and the way we influence our government can influence right around the world. And some people have more influence than others probably, but it's the potential is there to do it.
Can I just on that? I mean, China are doing things. They're building a zero-emission city at the moment, which is an entirely new city, which in 20 years' time is planned to, I can't remember how many million it will populate, but will have a zero carbon emission from it. So there's a new development that's happening around Elephant and Castle in London that's planning on being 40% sustainable on its power by reusing the waste from it, and then the aim is to wipe out Elephant and Castle as it stands and replace a new development right in the centre of the city. So there are movements in that direction.
Yes, I was very encouraged 2 or 3 years ago. I went to a meeting of BP property managers. You know, big oil men living it up in Bath for a few days. They met every year, 50 of them. And BP spends $500 million a year on buildings. They asked me to talk about climate change. I talked about it. But I discovered that the main reason they were there, or the main purpose of that meeting, was to educate them all in building zero-emission buildings. John Brown, the chief executive of BP, had given instructions that all BP buildings, commercial buildings in the future, should be zero-emission buildings. And there were builders there and architects and others telling these people how they could go about it. I thought, therefore, there you have the second biggest oil company in the world actually picking up that message and doing something about it. Well, if they can do it, then everybody can.
Yeah, and of course BP sponsor a research group in my department where they're doing just that, and they're doing research on building houses so it's natural flow through. And John Brown is about to, John Brown of Madingley, isn't he? He's bought a house in Madingley. Yeah, we'll see more of him, I hope. Last question, I think.
I was mentally drawing a parallel between, I can remember back to 1939, we were faced with an enormous crisis then. And the people got together with information was put out by the government. And we were saving paper, tin cans, bottles, we seem to go around the cycle again. But is the information getting to people now, or how? Because you're driving the motorway, and I, being a lawyer, toddle along at 70 miles an hour. Everybody drives past me, wasting fuel. I've been in public buildings that are overheated, so people open the windows so that the heat out. Or we have beautifully sunlit rooms like this, and we have the lights on. We're in a blame culture now, and we blame the United States because they waste 25%. We're getting the message through, right? I was over in Canada, the big conference was on in Montreal last year on following Kyoto. And one of the journalists, were being rather honest there, was blaming that crowd down south for increasing pollution, CO2 pollution by 14%. But he admitted that Canada that had signed up to Kyoto had increased since then by 20%. It's always them. They were very much in a blame culture now. But is the message getting through to everybody? How do we generate everybody doing something? And from the small scale upwards.
Sure. Well, there are good stories and bad stories, and it's. I believe it is gradually penetrating, and even in countries like the US. If the US changed at top level, that will make an enormous difference.
Yeah.
So if you're praying people, pray for President Bush. People around that they will get some Damascus Road experience of some kind that will turn them into people who will, because that would have the knock-on effect of that around the world would be absolutely enormous.
Yeah, it's very interesting that E.O. Wilson, who's a very prominent secular humanist in the States, has just written a book, and he addresses the Christians notionally in the South. And he says, there's 30 million of you, you have creation care at the heart of your gospel. There's only a few thousand of us humanists. Why don't you do something?